Namaskar, warm welcome you in this live interactive session present by CIET NCRT and session of 5-day, 5-hour online training program on topic ICT for teaching learning of mathematics. So, in this day 1, we are going to learn this topic ICT for teaching and learning of mathematics, policies, perspectives and scope. So in this 5-day, 5-hour online training program, you can also become a part of this training program with register yourself, and post assessment program will be with you in after 5 days program, and you can become a part of this, and you can take a certificate after getting 70% of marks in this post assessment program. This program is organized by Central Institute of Education Technology, CIET NCRT. My name is Rajan Rajput and you all are watching us on eVidya channel number 6 to channel number 12, and beyond this medium you are also connected with us through the various mediums like NCERT official, our YouTube channel, and NCERT PM eVidya class 6 to class 12, our another YouTube channels. So if you have any queries and doubts regarding this topic, regarding this 5-hour training program, so let us know through the various mediums. You can make a call to us on the number is flashing on your screen. It's 8800440559. Or you can write a mail to us on training.helpdesk@ciet.nic.in. Another medium is the medium you are connected with us, that you are viewing with us. You can write your comment and queries in live chat box option of NCERT official YouTube channels page. So in this program we are discussing this topic ICT for teaching and learning of mathematics. The learning of mathematics often presents challenges for both educators and learners, and in this program we are discussing with this our resource persons, that we are with Dr. A.K. Vachalwar, professor in DESM NCRT New Delhi. Sir, namaskar. Warm welcome.
Thank you.
We are with Dr. Angel Ratnabai, ma'am, assistant professor is in CIET NCRT New Delhi. Ma'am, warm welcome. Namaskar. So in this program we know the topic and the mediums through that you can connect with us. So now let us learn how you can register yourself. Ma'am, Angel ma'am, can we learn that how the viewers can register themselves?
So about all these programs, you have all the details in the CIET website.
Yes.
So when you see here, like you'll go to the CIET website, under the activities, you have a tab under the activity, you have something called as workshops and training. So when you click on this, every program that's happening as an online training, you will be able to see this. So that this current week 14th to 18th we are having the training in English version, and in the upcoming week the session will be in Hindi version also. So please connect with us. To know the complete details, click on the title of the training. You will come to know what are the 5-day session is going to be on. So you can go through the titles of the sessions here, and kindly register yourself using the link which is given for registration, and watch live every day here in the YouTube official TV channel, or you can also watch in the DTH TV channel. So any one of the means you can use for watching the sessions. Even if you miss out the session watching in live, you don't need to worry about it. There will be a complete live session together as a playlist link. You can go to this playlist and also watch that. But for you to get a certificate, for just learning, it's enough if you watch. But if you wanted to get a certificate, you need to register yourself in the course, which will be released on the 5th day of this program. So the English version course will be released at the 5th day of this week, which is a Friday. So you can see the link which will be updated here in this place. You have to join the course, go through all the materials, take up the assessment and score 70% and above to get your certificate. Do not forget to give your feedback also in this form, so that you will be able to complete this course on your own.
Yeah, so in this day 1 we are talking about ICT for teaching and learning of mathematics, policy, perspectives and scope. So we are with Dr. A.K. Vachalwar. Sir, let us know how learning of mathematics happens.
Srijanji, mathematics is an abstract subject.
Yes.
You can't see the things that are happening in mathematics, but there are principles that are involved in doing mathematics. And so, in order to learn mathematics, you need to apply yourself, try to understand the principles behind that, and in understanding these principles, one has to apply herself or himself through different ways. Either it could be through some problems, it could be through some activities, it could be some digital resources through which we are able to understand the things. And there are many different tools that could be used for visualizing the things. See, the visualization is very important in mathematics. Once I am able to visualize, and then my thinking process starts applying itself, and I am able to think in a better way what I can use, in which situation I can use, how I can use, all these things I can do for learning of mathematics. Children are expected to verify the different principles. Unfortunately, what happens, this verification thing remains as it is. See, mathematics is a beautiful subject. It is a subject of patterns, of learning patterns, how patterns are developed, how patterns emerge, how patterns can be extended further. So, it is all about thinking, and generalizing these patterns is very important. So, mathematics involves patterns, seeing the patterns, extending the patterns, generalizing the patterns, and so on. And children are required to identify and find the exceptions to these generalizations as well. So, this particular thing it happens in mathematics, and once we get involved in this particular process of finding out the things, automatically you are getting involved in the learning of mathematics. Over the last 2 decades, technology has changed the way the world works. We can see around us how technology has developed, how in different fields technology has made a great impact, and mathematics, and particularly the education sector, is no exception to that. Technology has made its impact on the education sector as well, and particularly for a subject, abstract subject like mathematics, where you are not even able to see the numbers, you are simply talking of numbers, we are talking about the principles about the numbers, but you are not able to see the numbers. So, to get these visualizations, the technological tools are very important. Visualization does not mean that seeing the letter, the particular symbol 1, 2, 3 on the screen, but it means that you are able to think about the concept that lies behind the symbol 1 or behind the symbol 2, and how they are operated, why one is less than the other, how they can be added, how they can be subtracted, so on and so forth. So, technology helps you to do that, to provoke that particular thinking and take you to the desired goal. And effective use of technology can enhance student learning by developing their understanding, stimulating interest, and increasing their proficiency in mathematics. In addition, strategic use of technology promotes equity by allowing greater access of mathematics by all students. In one particular program, there could be so many students, so many viewers that could be attached to that program. They can learn lots of things in that particular program, which cannot be done in a classroom situation. So, technology has got its own advantages, and one of these advantages is this: not only the visualization of the concepts, but also that at a time so many people get the idea of mathematics, mathematical thinking, ideas of mathematical concepts through the screen. Due to the rapid improvement of technology, the world is changing more quickly than ever before. So, the future is even more uncertain. The children born from 1980 to 2000 are known as the net generation. They are more dependent on digital resources. They know more about the digital things, the ICT things that we call them. And so, why not use mathematics why not teach mathematics or learn mathematics through such digital sources? That was thought about. As a result, it is important to equip students with not only academic content knowledge, but also with general skills that will enable students to face any situation. Now, if I want to learn mathematics through digital resources, I need to know how to operate the computer, I need to know how to operate the digital devices, then only I will become confident in learning the concepts of mathematics. And so, children will become proficient in learning mathematics, reading, writing, etc., while using the technology. It is no longer enough for students to be proficient in mathematics, reading and writing, but students need to have more tools at their disposal, how to make use of the digital things in the learning of mathematics. There could be different ways of doing that. So, if I know one particular way of doing that, I can explore other ways of using the technology to learn the mathematical concepts effectively, because it really requires abstraction, it really requires visualization, and it is an abstract subject. Information and communication technology, that is ICT literacy, media and internet literacy, data interpretation and analysis, computer programming, etc., are the 21st century skills where the students need to be made more proficient, and if they are made more proficient in this, their learning of mathematics will definitely improve and make a good impact on the society. Now, there are different types of technological tools that are used, like content specific tools and content neutral tools. Content specific tools will include hardware and software such as calculators, computer, algebra system, dynamic and interactive geometry software, etc. Learners can use these tools for computation, construction and representation as they explore the problems. We can see that while doing the geometry problems or while doing the algebra problems, if we use the systems like GeoGebra, Desmos calculator, etc., it becomes easier for me to do the things and see the things on the screen, how the diagrams are made, what is the principle involved in that, and many times I try to explore the principle of making a circle, making a square, making different quadrilaterals, making different polygons, and then I try to explore their properties while doing that. So, technology in a way helps us to do that. And content neutral tools will include communication and collaboration tools, web based digital media, presentation software, hardware such as interactive whiteboards, etc. These tools enhance access to information, improve collaboration among students and teachers. That is more important, because what we expect is that there should be a collaboration between the peers, between the peer and between the student and the teacher, and so that if there is a talk among them, if there is a information exchange between them, then automatically the vocabulary improves. Children or the learners learn more about how to use the mathematical vocabulary and effectively, not only effectively but under different situations, and this particular thing can be facilitated by using the technology. So, it provides opportunity to develop more effective presentations and promote communication among these stakeholders. Mathematics should emerge as a subject of exploration. It is not just a dull subject that something has been proved and I have to simply rote memorize it, but some problem or some situation is put before me, how to explore, how to create a problem and how to explore in that particular situation is more important. So, exploration is important for deepening our understanding of mathematical concepts. The mathematics classroom should not expect a blind application of ununderstood algorithms in different situations, because if a certain formula is given to me, it is not just expected that I use it anywhere I want. I have to think about how to think where to apply this particular algorithm. Can I find some other place also where this can be used? So, in this way I think we can make use of technology for doing this. For example, in generating proofs in geometry, what happens? The figures constructed are models of ideal dimensionless figure, as said by Euclid. The figures which we see on the notebook, even the point, the line segment, the line, etc., they are not the real figures, I will say, the ideal figures, but as per Euclid, a point is a dimensionless entity. Then how to imagine that? The line is something that extends without any breadth. How to imagine that? So, to do this we have to create these pictures, we have to think about these pictures, and then only we can think about the principles behind that, and this particular thing is facilitated by geometry. The GeoGebra or the Desmos calculator things are very useful in doing this. We can create different figures using the different algorithms that are present there. It has to be close to the experience of the students, of the learners, because once the children enter the realm of abstraction, they till the primary stage the students are in touch with the real things, the concrete things, and suddenly they are starting to move towards the abstract principles, and in order to do that the children will have to be made aware about the abstractions. So, the movement from the concrete to the abstract is a very important thing that is that needs to be taken care of, and so learning to abstract helps formulate and understand the arguments. That is more important part of learning of mathematics. The National Education Policy 2020 suggests introduction of a new curricular area of computational thinking. Again we are moving from mathematics to its use using the computers, where in computational thinking what we do is we break up, we have a problem, we break up the problem into small parts, try to understand each of the parts and try to link each of these parts to each other, so that our algorithm is generated and we are able to understand the things properly. So, coding is one thing that is the 21st century subject where mathematics can be used, and students are expected to learn about this coding. The approach to integrate digital literacy in the early years of mathematics should be to use ICT as teachers' aid to explain the application or provide the visual context of abstract concepts. Example, converging lines, decimal, fractions, integers, and more numbers we are trying to create, more concepts we are trying to create using the concepts that we have learnt, that the student has learned in their earlier classes, and that needs to observing harmony between the practical application and theoretical concepts of mathematics. So, more and more when we are moving towards the theory, our interaction with the contexts that are there, the concrete objects that are there, that is more important, and that helps us to move towards that. So, the use of technology will help us in moving from concrete to abstract, and so inquiry and contribution of mathematical reflection, problem identification, decision making, all these things which are a part of mathematical thinking are very important, and technology helps us in different ways in doing that. The use of technology cannot replace an excellent teacher, that is undoubtedly true, because a teacher in the classroom definitely influences his or her teachers through her interaction, but technology definitely has got something that the teacher can use in the during the classroom transaction, and this particular use could be more effective than what they are doing right now in the classroom. So, along with their pedagogical knowledge, along with their pedagogical skills, one of these things could be about the use of technology. Technology provides an opportunity for teachers to rethink fundamental pedagogical issues in teaching and learning of mathematics alongside the approaches to learning that students need to apply in classrooms. So, these are many of the things that the teacher can use in their classroom teaching. Teaching is being viewed as a process of facilitating students' learning by creating a learning environment, and that is why we say that teacher is a facilitator. She will she will have a situation before it, and she will create a situation in which she can ask the students to explore it. She can indulge the students in exploring that particular situation, so that the understanding about the mathematical concepts of the children can be enhanced. There is a need to integrate technology used in mathematics curriculum at school stage itself, so that students become proficient in using the technology in learning of mathematics, and so the students will become more proficient in the thinking skills. That is more important. The logical skills, the logically thinking skills are more important, and so we expect that this technology can be integrated along with mathematics right from the school stage. Appropriate professional development is key to assist teachers not only in the use of new software tools, but also introducing a variety of ways by which they could successfully utilize technology in their teaching practices. Software applications are resources, and it is more important to think about the nature of the user's experiences. Use of software can be invoked in two distinct ways. One is you prepare certain program and give it to the students to explore, and the other is you can ask the students themselves to prepare the program and develop the mathematical concept that is involved in it. In which situation suits your classroom is more important. You only can decide about it, and thereby the students would be benefited accordingly. So, by a more open application or resource you can do that. So, there are a few resources which you can see: ePathshala, NROER, Digital Diksha resource, then MOOCs is there, Swayamprabha is there, GeoGebra as I said earlier, and Desmos calculator. So, all these things can be used as a technological tool in your classroom, and you will be benefited, and your students would be benefited in doing that. So, would you like to say something now? Okay. So, I will continue about the GeoGebra applet. The power of software such as GeoGebra lies in the way its users interact directly with geometric figures they have constructed or that have been pre-constructed for them. So, as I said, either the students construct the mathematical concepts, the figures, the diagrams, the principles, the algorithms on the GeoGebra applet, or they can be given to the students to construct them. So, this interaction occurs in a continuous and dynamic way by means of the direct control of one's hand on the mouse. So, that is very simple, just with the help of the mouse on and by looking at the things that are happening on the screen, one is able to think about the different concepts that are involved. So, for us the most striking and powerful impact comes when, in pursuit of a mathematical question or goal, students directly explore a geometric realm while interacting with their hands, eyes and focused minds. So, in order to explore a certain problem, in order to find the solution for a particular problem, when they suddenly come across the solution of the problem while using these applets, the students are really thrilled to understand that, to know that, to observe that, and that is the most important part of learning mathematics. So, one of the issues in describing the concepts in text is that one necessarily misses the visualization aspects. Not least among these is the sense of surprise, that is more important, surprise and wonder that animating mathematical diagrams and images can bring, externalizing and setting back in motion images that can bring that have been held static within the pages of the textbook. So, if you see a diagram of a circle, of a diagram of a cube or a diagram of a cuboid in the textbook, they are static diagrams, but when you see actually on the screen and the student is able to move those things in different directions and through different angles, and they can see the different aspects related to that, they are able to find out the different attributes related to that particular diagram, be it a two-dimensional figure or be it a three-dimensional figure. The student will be able to explore that and they will enjoy doing this particular thing. In other words, we must confront the decision of offering users pre-constructed files to explore versus providing students with tasks that require construction of their own figures. That will be more challenging. If they construct their own figures, they will automatically come to know about the attributes of those figures. And as always, there is a general pedagogic question like what kind of questions and tasks and help students to focus their attention on the mathematically important aspects of the situations presented to them by others or generated by them. This is an important aspect of learning mathematics, asking questions and finding solutions and seeing the different aspects of that algorithm or that particular concept. So, this is more important. So, in effect what I will say is ICT plays helps in developing the imaginative powers of the students rather, because mathematics is more of imagination. Logically the students have to justify whatever they say, and that is why this tools, the ICT tools help students enable new types of teaching and learning styles. At present mostly they are being used to support the traditional learning practices, but we are moving away from these rote memorization things. So, that is why it is advisable to use the ICT while teaching of mathematics.
Yeah. So, you have been very clearly explaining with examples about how technology has a scope in teaching and learning of mathematics, because we were just going through certain examples where you were very clearly saying how abstraction is there in mathematics, and it is also required how technology can help in understanding that abstraction, and also in the process of learning itself. But it is also very important to understand like what kind of environment has to be created or what kind of teacher empowerment is required. Being a maths teacher, we have been trained very clearly about the content. We know how to use different methods to teach mathematics. But right now, what could be a scope for as a maths teacher? Now, what am I expected to build in myself so that I can use technology in the classroom as well?
So in order to bring this, we need an inquiry based culture. We need a community of explorers, because that is more important. See, one person exploring and a group of students exploring a particular concept makes a difference, and students get more involved in it because there is a lot of conversation between the students about that particular concept, and so there is more of arguments, the yeses and nos that goes behind it, and that is why the deepening of knowledge about that particular concept happens. Curiosity is there, creativity is there, questioning, all these things are valued, because when I am trying to explore a particular thing, it strikes me what are the things I require, how will I get those things, automatically these things come in my mind, and so that questioning attitude, the creating something out of that particular situation, all these things are automatically developed, and my curiosity increases. It makes me curious about things around me, because mathematics comes from the things that are around me, and then trying to logically frame these things in a particular way. Then resources and opportunities are made readily available, that is more important, because if I do not have the resources, if I will not be able to function properly. If I do not have computer, if I do not have the other things that are necessary, the laptops etc., then it will not be possible for me to explore the things digitally. Students can work like scientists engaged in the process of collective sense making. So, they need to think about themselves as mathematicians. They are trying to create some mathematical thing, a mathematical algorithm or a mathematical concept. They are trying to create that, and then they will know the importance of the small concepts that are involved there, how these concepts make a difference if one thing is there and one thing is not there. For example, in the case of a quadratic equation, when I say ax square plus bx plus c equal to 0, what is a, what is b, what is c? They are all real numbers. Then what if I say right there a is not equal to 0? What happens if I say a is equal to 0? Will it remain a quadratic equation then if it becomes 0? So, these small things the students will understand if such queries are made, and they will see for themselves that how important these things are there, which are there in the textbook. They are just dryly put down in the textbook, how live these things become automatically. And once I realize how the things become live, then I really take interest in the learning of mathematics. A variety of changes must be implemented to optimize teacher use of ICTs. Shifting pedagogies, when I use ICTs, there could be different pedagogies I can use. I can use some different forms of questioning, and I can get some different forms of getting answers from the students, so on and so forth. Redesigning the curriculum and assessment. Assessment is important. What is to be assessed? When I am changing my mode of talking to the students, when I want that students should learn something, think about it, then I have to test their thinking, not just what they have, what content they have learned, whether they know the formula for a circle or not, area of a circle or not, or whether they know the formula about the area of a square or not, but the way the formulae are developed, that particular aspect becomes very important, and then forever it remains with them, and this particular habit of thinking goes with them throughout their life. With sufficient enabling factors in place, teachers can utilize ICTs in as constructivist a manner as their pedagogical philosophies. So, that is what the constructivist approach will help. I mean, these ICT tools can help the constructivist way of thinking, constructivist way of doing things and learning mathematics.
Yes. So, very well said. What we can understand from the discussion as of now, I would like to re-insist on few takeaways from what we have discussed till now. The number one is like Macs have a lot of scope to use technology so that it can help us to visualize better mathematics, to understand abstraction. So, and sir has given us lots of examples, but to put it in one shell, if a teacher need to really use technology for teaching learning of mathematics, the very first point in our mind is, first of all, the teacher has to understand how to use appropriate technology appropriately according to the content and the methodology. So, that is where the TPAC comes in. TPAC, we all are aware about the techno-pedagogical content knowledge. It's very important for a teacher to have not only the maths content knowledge. It's not sufficient for a teacher only to have the pedagogical knowledge of how to really teach that mathematics, but it is also important to have the technological knowledge and its combination with for which content, which technology would be good. Sir has given enough examples when we wanted to show the 3D objects, like when we talk about 3D or 2D, there is a dimension to be shown, they should be able to see it. In that cases, we need certain simulations to be shown to them or animations to be shown. So, selection of the media, selection of the digital resource is very much dependent on the content and the way we wanted to use in the classroom. Maybe I wanted to construct step by step. I want to teach the children about like a particular theorem, which is a generalization that has been made. So, I need to show now for case 1 this is true, case 2 this is true, and then go on and show multiple cases to the student. Then in that case, I cannot use a PowerPoint or an fixed animation. I need a dynamic tool to use it in my classroom so that I will be able to show them. When I change this, this is what happened. When I change this parameter, this is what happens. So, it is very important for a teacher to really understand and also select appropriate digital tools. So, if we can see to put it all the discussions in a nutshell on the screen, we could see that NEP very clearly talks about our national policy recommends that we need to use technology to enhance our teaching learning process. That's the first recommendation very clearly given in the national education policy. And when we read about how technology related recommendations are given, use of quality digital resources have been emphasized for you teaching and learning of various subjects. So, one of the things which it's a very effective is it's not just the softwares. There are first category there are different digital resources that we can use for teaching learning of mathematics like audio, video, simulations, virtual lab, all these are digital resources that can be used. And there are, as already sir has also categorized about, there are certain subject specific tools and there are tools which are very common. There are tools like which we use Kahoot or Mentimeter or simple presentation for the sake. All these are generic tools which can be used for delivering maths content. But there are subject specific tools like Desmos, GeoGebra, like RoboCompass. These are some of the very specific tools we can use for teaching particular maths content. So we need to really have an understanding and knowledge of these subjects to really use technology effectively in the classroom. So that is what NCF also talks about, that every mathematician, the term mathematization itself is not just going and telling that learn some content, but it is more about developing a mathematical mindset. So we are not expecting our children to just learn some content and go ahead. The objective of teaching mathematics is really to build a mathematical mindset using logical reasoning, problem solving, pattern recognition and abstract thinking. So this is what we have been discussing, how this technology can support. So NCF very clearly points out that technology can help us in building that mathematical mindset in children. So one benefit of using technology is to achieve what we have planned in that policy and what we are recommending in the NCF, we will be able to achieve by use of technology. So some of the very specific points was told that we need to visualize mathematics. It's very important. We don't see mathematics with our naked eyes, but we need to visualize mathematics, visualize abstract concepts. And when we think of mathematics, so if we can also see, there are some examples we have just mapped it, like when you wanted to visualize abstract concepts, you can use some 3D modeling softwares, we can use AR, augmented reality tools, so it will help us to visualize mathematics. And there are one thing we also pointed out, that we can use technology to develop mathematical thinking. So there are tools, very dynamic tools like GeoGebra, Desmos, like coding, robotics related tools. This can help us to really have that mathematical thinking. And sir was pointing out a very the last point which he was mentioning is about it should encourage constructivist learning, because we are expecting children to be innovators. They have to become their own developers. They have to become creators. So when we use learning tools that give scope for them to build, construct themselves. So there are several tools that can be used and not only in the classroom, we can have a flipped classroom, like you give the tools to school home, that they can construct at home, build experience it and come back to the classroom for discussion. So these kind of digital tools also helps us in implementing innovative pedagogies like blended learning and flipped learning in our classrooms. Not only that, it helps us to observe the patterns and generalize. So I have studied till mathematics, but whenever we just ask ourselves how many theorems which we learnt, or how many theorems we learnt it as how many generalization we learned, we could really visualize and learn. Many times we memorize that or we just derive it. We don't really see that. So it is very important to see. To see, we need digital tools that can simulate the environments. They can simulate the content which we are teaching them, so that the children will be able to observe. And not but the least, mathematics has one very important point, is the problem solving. And problem solving, there are several tools. Today, data visualization, we have tools, not just spreadsheets, but you have data visualization tools. We also have lots of games, digital games that can help them to quickly solve the problem in a very gamified manner, so that children are engaged in the classroom irrespective of which age they belong to. The games are age appropriate. Games are there, starting from children to just play a game with the cartoon characters, to solve addition and math subtraction, even till the higher classes students working on like understanding. Even many times we would have seen children playing Angry Bird. That's a very simple game, children keeps playing, but you can see that we talk about all the trigonometry principles we learn is there applied in that game. So without knowing the proper angle, without knowing the triangular properties, a child cannot do it. Properly they cannot play the game. So without even having that knowledge that they are applying mathematics. Today there are n number of games where they do. Children do quick mathematics calculations when they play like games like business and all that. When they play, like they go and buy farm, they just look about profit, they think about loss, all these content. They, without really applying, thinking that they are applying mathematics, they play. So digital games have become one of the like a rich resource for us to practice problem solving. So this is how we can bring up various tools into our classroom so that our children will be really benefited out of using this. So just to conclude, like we wanted to say that there are we are going to continuously learn in the next 4 days how we can use different digital resources in teaching and learning of mathematics. Today we have tried to understand, is there a scope for using technology in a maths classroom? And we have come out to an understanding that yes, it is possible. And we also have several e-content, digital content in various forms that can be used. There are several open source which is available, which we can, which we are going to learn about. And also we wanted to know like how simulations, we have introduced a lot of terminologies today, simulation, augmented reality. There are certain assistive technology for children who are disabled also to use and then learn mathematics. So there are so many different digital apps and mobile apps. So next 4 days, let us join together to learn. Next 4 hours of learning is to understand various ways in which we can use digital resources and digital technologies for teaching and learning mathematics. Stay connected with us to learn about this. Thank you.
Yeah. Ma'am and sir, I'm so happy to mention here that so many viewers are appreciating our today's session, fruitful session, informative session. They are commenting, and we have some questions. Let's quickly take this. Sumandra Roy want to know that are there any other softwares applications similar to GeoGebra?
Yeah, we would like you to be connected because we have 4 sessions if you have seen. Coming up, there is one dedicated session to understand various tools that are available. So we will be discussing that. So please be connected.
Yeah, and ICT tool is good for learning mathematics, but which software is easy to learn for poor students? Mr. Gonal want to know that.
See, that is why we are introducing all the content which is available as open educational resource and also the softwares that are available as free and open source software. Why we are introducing open educational resources? It is completely free. It is not, it is going to help like poor, rich, children who has access more, doesn't have an access. So where to get these open educational resources, how do you get it, where to get it, we will be discussing in one of the sessions. But all these open education resources are freely accessible for children to use it. And not only that, the softwares which we are going to introduce you in this particular 4 days, they are all free and open source and which is available for free for teachers to just use it. It's not just teachers, even the students can access it very simple way using their parents' mobile, or like if they have a computer, they can install in their desktop, laptop or in the tab. So we are going to introduce such tools. Yes. So there are a number of tools which can benefit all the children.
Yes, Siva wants to know that please share the list of activities that can be used in schools with the help of GeoGebra and which age group is appropriate for such utilities.
Okay. So we will surely share this because like as part of this 5 days training, we are not going to share you some activities, this particular trainings. But if you see in NCERT portal, we have already uploaded lots of this kind of activities, and we also do sessions already how this tools, this particular activity should be implemented in the class. During the live session for teaching of mathematics, such sessions are already taken. We recommend all of you to just watch not this 5 days training alone. Yes. After this, kindly connect to watch the sessions from NCERT in the PM eVidya TV channel and in the NCERT official channel when there is a particular topic is taken from a particular class and it is explained how this particular topic has to be taught with with the use of
Definitely,
technology.
yeah.
So that will surely help to understand the activities.
Definitely. So we are learning in day 1 ICT for teaching and learning of mathematics, policies, perspectives and scope with Dr. A.K. Vajalwar, Professor DESM, NCERT, New Delhi. Thank you so much for today's session,
Thank
sir.
you. Namaskar.
And we are with Dr. Angel Ratnabai, ma'am, Assistant Professor from CIET NCERT, New Delhi. Ma'am, thank you so much for this beautiful and informative session.
Thank you.
So, dear learners and viewers, in day 2, we are discussing audio and video resources for teaching and learning of mathematics. In some minutes, we are with you, our next session of Sahyog session. And topic for today's Sahyog session is quality friendship for adolescents' mental well-being. So please connect with us through the various mediums. My name is Rajan Rajput and have a good evening. Time to wrap up the show. Namaskar.